So the screen is visible to you. I'm audible to you. I have launched a poll, so quickly response in the poll, then we'll start the class. Okay. Quickly response in the poll. Okay, so approximately everybody can see my screen and I'm audible to everyone. That is the case now. Okay, so we will start the today's lecture. Sorry for being late. Uh, so this is your Enable Plus class 12th physics, and we are moving on with moving charges and magnetism. In JEE means this chapter is categorized as a magnetic effect of current. Okay, so this is our lecture number 3. In the previous lecture, we have seen ki what type of Lorentz force that we study. The Lorentz force is the combined effect of electric force and magnetic force. Okay, and we have seen that ki there will be no power generated by the magnetic force. There will be no work done by the magnetic force. All the property we have dealt with. Okay. Finally, we came to the conclusion कि what is Biot-Savart law. ठीक है. What is Biot-Savart law? Biot-Savart law का application we have also seen. What is the application of Biot-Savart law that we have also seen in the previous chapters. Okay, so today, first of all, we are going to do some numerical in the due respect to the previous year examples, or the topic that we have seen in the previous class, the concept that we have learned. We will going to do the numerical based on that topic so that you will have more clarity on these topics. Okay, so once again I welcome you all in this lecture. Let's just start the lecture. So this is the force, this is the question that I want to present in front of you. Find the magnetic field at the center of a current carrying conductor bent in the form of an arc subtending some angle at its center. Radius of the arc is capital R. So try to solve this question. Okay, in these types of questions na, you will find indirect questions in your examination, like it will give you some angle, give you an arc, give the length of the arc, radius of the arc, and then you have to find out. Okay. Okay, so let's just start to solve this question. Suppose we have a arc here. Just a second. This is the arc. This is the axis of the arc. These are the two axes, and here we have the arc. This is the arc that we are talking about. Okay, this is a current carrying conductor. We simply bend it into the form of arc. Okay. Okay. So this is the direction of current flow. The I current will be flowing into that. So the concept here to solve these types of question is just to have a elemental length. Okay. Elemental length we will talk about, and we have talked about in many questions. So we consider an element here of dx length and try to calculate the magnetic field due to that element. Okay. And then we will have the then we will integrate it for entire length of the arc. Okay. So we will be considering, not, this is a semicircular arc by the way, so we will be considering only a portion of the arc. Okay. Just a second, let me redraw this. So are you guys on holiday? Have you reached your home or you are currently in the schools? And let's say this angle, the complete angle of the arc is theta. Okay, radius of the arc is capital R. Clear है? Now what we will do, we will consider a element here. ठीक है, this element of dx length. Clear? Now we attach to it, to the center, so it will directly subtending some angle, and the angle that it will subtend by this end is phi. Let's say phi. ठीक है, so at phi angle from this end we consider a current element, and the angle that the current element subtend, it is also d phi. Very small angle because very small current element. Okay. चलो ठीक है, so d phi is the angle of this small arc of dx length. ठीक है? So what we will do, we will find out that what is the current carrying by this. So suppose the direction of current is this. This is the direction of current I. Okay. Now we know that the magnetic field will be very small. dB is equals to mu naught upon 4 pi I dl sin theta divided by r square. This is all we know. ठीक है, अब देखो यहाँ पे what is the distance small r? Small r is capital R because this dx element is at capital R distance from this point. We want to know the magnetic field at the center. So that is why if you see at this point, this is the center. The distance of this dx element with the center is capital R. So this expression would modify it as mu naught upon 4 pi I dl upon capital R square into sine theta is what? Theta is the angle between current element, which is dx, and the position vector at this point. So position vector is this r, dx element is this. So the angle between them is 90 degree. ठीक है, so it will become sin 90, and in place of dx, चलो dx की जगह वो would take at dl. ठीक है, so यहाँ पे सिंप्लीफाई हो जाएगा ये. क्लियर है? अब देखो, we need to integrate this. dB is what here? dB is equals to mu naught upon 4 pi I dl अपॉन आर स्क्वायर. ठीक है, इसमें किसी को कंफ्यूजन है एंगल का? कैसे लिया एंगल? एंगल इज बिटवीन डीएल वेक्टर, this is the dl vector, and the r vector, this radius vector. So radius is always perpendicular to the arc. ठीक है, we know that from geometry also. Clear? So this is dB is equals to mu naught upon 4 pi I dl upon r square. Okay. Now if you integrate it, we need to integrate this dl. What is this dl? ठीक है, so dl क्या होगा? चेंज होता रहेगा. वी कैन चेंज इट. dl is varies from here to here. ठीक है, and what is the length of this arc? If you will see length of this arc, we can say, suppose the length of this arc is capital L. So capital L को we can represent in some in terms of theta. Capital L is what? We know that angle is equals to arc upon length. arc upon radius. Arc length upon radius. This is the formula for angle. ठीक है. Now angle is what? Theta. Theta is the angle here. Arc length is what? This is the arc length. Let's say capital L divided by what is the radius, which is capital R. ठीक है. So if I integrate this element, which is dB, so net field that I have is B net here is, when I integrate this dB, integration of dB is equals to like mu naught upon 4 pi I or capital R square. These are the what? These are what? These are constant. So we can say these are the constant. So integration is only for dl. Integration is only for dl. ठीक है. So here, if you integrate dl, which means you are talking about the complete length of the arc. ठीक है. So complete length we have calculated. It is theta into capital R. So we can say that B net here is mu naught upon mu naught I upon 4 pi R square into theta into capital R. Can we say that? This R and R will cancel out. So finally B net what we have? Mu naught I upon 4 pi R into theta. This is the formula, or this is the expression that you would remember. Okay, you should remember this expression because it will help you a lot to calculate the what is the magnetic field at the center of any arc. Suppose we want to calculate the magnetic field at the center of circle. So for circle, what will this angle will become? This angle would become, बताओ, comment box में बताओ. कमेंट बॉक्स में बताओ फॉर सर्कल व्हाट वुड बी द वैल्यू ऑफ दिस एंगल थीटा. थीटा की क्या वैल्यू होगी? अरे एनीवन रेस्पॉन्स यार, रेस्पॉन्स प्लीज. व्हाट वुड बी द वैल्यू ऑफ दिस एंगल थीटा फॉर अ सर्कल? 2 पाई. वेरी गुड बिशन. So 2 pi you are saying, na? So for circle, for circle, theta would be equals to 2 pi. When you put the value here, it will give you 2 pi. ठीक है, 2 pi यहाँ पे आ जाएगा 2 pi. So 2 pi से 4 pi will cancel out by 2 times. So you will have mu naught I upon 2r. ठीक है. Very good to all of you, those who have responded. Or one thing you need to remember in this, कि always you need to put the value of angle in terms of pi. ठीक है, not in terms of radian. ठीक है, not in terms of degree. So when I talk about the angle for a complete circle, You need to put it here as theta is equals to 2 pi, not 360 degree. ठीक है. Now this one, try to solve this one. Very easy question और बहुत ही interesting question है. ठीक है. Try to solve this. देखो, a very long thin strip of metal of width p carries a current I along its length. Find the magnetic field in the plane of strip at the distance from the edge nearest to the point. Like, guys, give me just 1 second. Give me. Sorry, guys, for the interruption. Do you know? Let me tell you one thing. पता क्या हुआ? Today there is no electricity at the time of your class. Your class timing is 3, so there is no electricity in my town. So, and my laptop is dead also. So that is why I have click some physics and try to attach it with an inverter, because there is no inverter supply here. Now the light has come, so I have to make the disarrangement there. ठीक है. So thank God. चलो, start the class again. So एक बहुत ही लंबी thin strip है of metal which carries a current I, और उसकी जो width है that is B. ठीक है. So इसकी जो width है this is B, और ये करंट कितना लेकर के चल रही है I. हम्म. Find the magnetic field in the plane of strip at the distance from the edge nearest to the point. So we have to find the magnetic field in the plane of the strip, इसी plane में, and at a distance from the edge nearest to the point. यहाँ से we consider a point here. Let's say this is the point P where we want to calculate which is the nearest. ठीक है, nearest the edge. So what we will do, अब देखो करंट ऐसे आ रहा है, तो टू नो द डायरेक्शन, व्हाट इज द डायरेक्शन ऑफ मैग्नेटिक फील्ड, जस्ट ट्राई टू curl your finger in the direction of current. Current is going like this, downward direction में. Put your thumb in the direction of strip, curl your finger, so you will see that your finger is coming up, which mean at this point the magnetic field is perpendicular to the plane of strip. ठीक है, दिस इज द प्लेन ऑफ स्ट्रिप, और ये क्या है, परपेंडिकुलर. दिस इज मैग्नेटिक फील्ड बी वेक्टर. डीबी वी विल कंसिडर इनिशियली. सो उसके लिए क्या करेंगे, अब देखो इसकी विड्थ भी है. ठीक है. अब इस पोर्शन से इस डिस्टेंस अलग होगी, ये डिस्टेंस अलग होगी, इस पोर्शन से ये डिस्टेंस अलग होगी, इस पोर्शन से ये डिस्टेंस अलग होगी. सो एज अ डिस्टेंस वेरीज द मैग्नेटिक फील्ड का मैग्नीट्यूड विल आल्सो वेरी, which means we are dealing with a variable situation. So for that also what we will do, we will try to, we will have a elemental width here, and that elemental width is dx. Make sure the ink is visible to you. So we consider a width dx because we have to calculate the magnetic field along this width. ठीक है. So हमने एक elemental width dx का strip consider कर लिया. Now by this strip what is the current? ठीक है. What will be the value of current? अब ये क्या है? Very long है, very long. Pay attention to the, pay attention to this keyword. Very long means infinite, infinitely long. And for infinitely long, I have told you what will be the formula of magnetic field is given by dB, very small, क्योंकि strip मेरी बहुत small है. So it will be mu naught upon 4 pi into current, let's say I dash, mu naught I upon 4 pi. A, A is the distance from this point. ठीक है. और इस dx point से इस पॉइंट की डिस्टेंस, इस dx विड्थ से इस पॉइंट की डिस्टेंस कितनी है? x है. So it will be mu naught I dash upon 4 pi x. I dash is the value of current in this particular strip of width dx. देखो ये कैसे हुआ. So we have discussed the formula in the previous class. ये मेरे पास एक वायर थी, इसमें एक करंट जा रहा था ऐसे, and we have calculated the point P here, the magnetic field we want to calculate. फाइव वन और फाइव टू एंगल गिवन थे हमें एक्सट्रीम एंड्स के. तो यहाँ पे मेरा जो बी आया था दैट इज म्यू नॉट अपॉन 4 पाई. ए, ए इज द डिस्टेंस फ्रॉम दैट पॉइंट, आई इनटू साइन फाइव वन साइन फाइव टू. Those who have attended the previous lecture, we have did the derivation. Now, if the strip is infinitely long, that case I have also discussed. So phi 1 will become 90 degree, phi 2 will become 90 degree. It will become 2. Okay. It will become 2. So here we will attach the 2. Okay. Clear? Now, so the magnetic field due to infinitely long wire is mu naught I upon 2 pi A. अब देखो I is also controversial here. This I is the total current of width B. So what will be the current of width dx? So इसके लिए we will use the elementary method. Total width B से current is I. So unit width से कितना current होगा? I upon B. So dx width से कितना current होगा? What will be the value of current from dx width? It will be I by B into D. Just multiply it. So you have to put it here. So dB is equals to, this is the value of I dash. I dash is the current in this width. ठीक है. So mu naught upon 2 pi x into I by B into dx. Okay. देखो म्यू नॉट 2 पाई I और B is everything is constant here. Only x is variable. X is the distance of strip which will be changing by changing the strip edge. ठीक है. So if you integrate it to calculate the total width, it will be integration mu naught I upon 2 pi B into integration 1 upon x dx. 1 upon x dx का integration, who will tell me what is the integration of 1 upon x? अब देखो, one of the thing that we need to clear with, what is the dimension of this? Sorry, I didn't hear you. Log x, very good. देखो, so इस एज का, इस स्ट्रिप का जो नियरेस्ट एज है इस पॉइंट के, वो ये वाला एज है. इसकी जो डिस्टेंस गिवन है वो a गिवन है. देखो, फाइंड द मैग्नेटिक फील्ड इन द प्लेन ऑफ स्ट्रिप एट a distance फ्रॉम द एज नियरेस्ट टू द पॉइंट. ठीक है, क्लियर है. अब देखो ये डिस्टेंस कितनी होगी ए, तो लिमिट वुड बी, एक्स की लिमिट क्या होगी, एक्स विल बी वेरिंग फ्रॉम ए टू ए प्लस बी, ठीक है ना। ए कैसे, एक्स कैसे वेरी कर रहा है, यहाँ से स्टार्ट होगा, ये डिस्टेंस कितनी होगी ए, और यहाँ पे एंड होगा, दिस डिस्टेंस वुड बी बी, सो लिमिट वुड बी ए टू ए प्लस बी, ठीक है। सो हियर द लिमिट वुड बी ए टू ए प्लस बी, और बी प्लस ए वी कैन से, सेम ही मतलब है, ए प्लस बी रख लेते हैं चलो, ठीक है। तो बी वेक्टर विल बी कमिंग आउट एज म्यू नॉट आई अपॉन टू पाई बी, वन अपॉन एक्स का इंटीग्रेशन, वेरी गुड गणेश, log x is there, ln x we will say basically, ln x is, and limit would be a plus b to a, so it will be a plus b minus a, which will be a plus b divided by, ठीक है। Now you can cancel out this, and simply you will have mu naught I upon 2 pi b into ln 1 plus b upon. For further calculation, you can expand the logarithmic expression and get the final value. ठीक है, अगर point is very very larger distance away from the strip, so you can expand the logarithmic and get a final result. ठीक है, and that final result would be, if a is very very greater than b, then b vector would become mu naught upon 4 pi a into I into, sorry, mu naught upon 4 pi a 2 I upon, बस, ठीक है, म्यू नॉट इंटू 2 I अपॉन 4 पाई। क्लियर है? एनी काइंड ऑफ डाउट इन दिस क्वेश्चन, so you can tell me. तो देखो, a tightly wound 100 turns coil of radius 10 centimeter carries a current of 7 ampere. The magnitude of the magnetic field at the center of the coil, ठीक है, take permeability of free space as 4 pi into 10 raised to the power minus 7 SI unit. So in this question most of the student would think that this is a tightly wound coil and the radius is also given. So this is a toroid. Mostly you will not have any idea. I will give you the idea what is a toroid. So you will confuse in this. Okay, what is a toroid, and you will apply the formula of toroidal, but you will get wrong. When it will talk about a coil, na, you simply consider a coil that we have discussed in the previous session. So due to this coil, what is the formula that is being coming out? Anyone? Any idea about that? In the previous session, we have discussed the formula of a circular coil, and that would be at this point P, what is the magnetic field P vector on the axis of it? It would be mu naught I upon 4 pi r square plus x square raised to the power 3 by 2 into, यहाँ पे भी कुछ था, 2 pi r square. So this formula you have to use when these types of question will come. ठीक है, until and unless it is not mentioned as a toroid, you do not have to apply the formula for toroid to calculate the magnetic field. Make it very clear. Okay, so if you apply the formula here, you take this is the distance x. Okay, when the point is at center, magnetic field at the center it is talking about, so you need to put x is equals to 0. When you put x is equals to 0 here, it will become b is equals to mu naught I upon 4 pi r square raised to the power 3 by 2, because x will become 0, into 2 pi r square. 2 pi and 4 pi will cancel out. Simply this 2 power will cancel this half power, so this will become r raised to the power 3, and upper side we have r square, so 2 power will cancel out. Finally the expression you will have is mu naught I upon 2r. Okay, now if this number of turns is also given, so just multiply with n. Mu naught I by mu naught I n. N is the number of turn divided by 2r. So mu naught की value is given to you as 4 pi. 4 pi into I की value is given to you as 7 ampere into 100 divided by 2 into a radius. What is the value of radius? Radius is 10 centimeter. Convert it into minute. 10 is to minus 2. So when you calculate this, you will get to know the one of the results from this equation. Okay, clear? But if you apply the formula for toroid here, which is mu node ni upon 2 pi r, okay, it will make the calculation very easy, and you can find it out here. देखो 4 pi 10 raised to the power minus 7, upper side में 10 raised to the power minus 7, multiply n is 100, I is 7, divided by 2 pi, radius is 10 into 10 raised to the power minus 2, 2 pi 4 pi 2 14. देखो आपको आंसर मिल तो नहीं रहा ना, इट विल बिकम 7 टू जा 14. ठीक है, सो 14 यहाँ पे कहीं पे भी मैच है. क्लियर? सो दैट इज वाई ओनली डू नॉट यूज दिस फॉर्मूला, अप्लाई द फॉर्मूला फॉर अ कॉइल. क्लियर है सभी को? Now we will talk about the ampere circuital law right now. What is ampere circuital law? देखो ampere circuital law is similar to the Gauss law in electrostats. ठीक है, so nothing much to be discussed about it. कि what is this, what is that, because we have a basic idea of Gauss theorem. What is the Gauss theorem? Gauss theorem shows that कि whatever is the charge enclosed by a closed curve, ठीक है, that is the statement na, the charge enclosed by a closed curve is only participated in the magnetic flux through that particular closed loop. ठीक है, whatever the shape of the closed, so the net magnetic flux, sorry, the net electric flux through that closed loop will be equals to 1 by epsilon naught times charge enclosed by that loop. ठीक है, in similar way here we are talking about current, we are not talking about charge. Charge is moving in this chapter, so moving charge will become current. So current say what we mean, apply the same but just change the word. So what we will say, the over net magnetic field over a closed loop is equals to mu naught times the total current passing through the surface of the bounded by the loop. Which means, suppose we have a loop here, any arbitrary shape, and there are wires passing through it. Okay, outside there are also wires in which there is a direction of current, random direction of current. Okay, so this is the closed loop which is bounded these wires only, these four wires. So Ampere law says that the line integral of b vector dot dl vector is only equals to mu naught times of current enclosed by the loop, arbitrary loop. अब देखो यहाँ पे suppose every current is value of I, so it will become mu naught into I plus I. अब देखो सेम डायरेक्शन का करंट यू हैव टू टेक पॉजिटिव, ऑपोजिट डायरेक्शन विल टेक नेगेटिव. सपोज यू आर कंसिडरिंग ऑपोजिट साइड. देखो, if you are considering upward side as positive, so you have to consider downward side as negative. ठीक है, so if it is positive, so 2i are also negative, so it will become 2i minus 2i. So the net magnetic field at the center, at this point, any point in this closed loop will be 0. Clear? So here the statement is that line integral of b vector dot dl vector is equals to mu naught times of I. I is enclosed. ठीक है, mu naught is the permeability of free space here, and I is the value of current enclosed. अब देखो इसे एप्लीकेशन के थ्रू ज्यादा समझ में आता है चीजें, एप्लीकेशन के थ्रू समझने की कोशिश करते हैं. ठीक है, देखो कुछ कंडीशंस हैं, we have to talk about some conditions and how and where we can apply the this ampere circuital law, same as we are defining some condition or criteria to apply the Gauss law. ठीक है, वैसे Gauss law is everywhere is valid. ठीक है, but there are certain limitation. We cannot apply the Gauss law at any arbitrary shape. We can apply but cannot able to deduce the results. We can only apply the Gauss law if you see, if you remember, to the non-geometries. ठीक है. In similar way, in Gauss law, we assume a Gauss surface. Here we are also going to assume a Ampere's loop, Amperian loop. ठीक है. So the condition is that it will be easy as to easy for you to apply the circuit law if you remember these three conditions. So if B is tangential, okay, to the loop that we are choosing and has a non-zero constant magnitude, only in that case. Second case is if B, that is magnetic field vector, is normal to the loop, in that case you can apply easily. And third is that if B vanishes everywhere on the loop, there is no B present. Okay. Now, देखो, what is the problem solving strategy for Ampere's law? So first of all, you need to draw a appropriate Amperian loop. Appropriate Amperian loop का मतलब क्या हुआ? Appropriate Amperian loop से क्या मतलब? Any arbitrary shape is not okay. ठीक है. Either you have to make a circle, you have to make a rectangle. तो both इन दोनों में ही काम हो जाता है. ठीक है. When you consider a circle or a rectangle. Second thing, find the current enclosed by the Amperian loop. ठीक है. What is the current enclosed by that loop? And third thing is calculate the line integral b vector dot dl vector around the closed. ठीक है. Suppose in this theorem, यहाँ पे there are two values of current, let's say I1 and let's say I2. ठीक है. There are two wires that is passing through this loop. Now we have considered a Amperian loop. This is nothing but a Amperian loop. ये क्या है? It's a Amperian loop. Okay. Amperian loop से आई हैव टोल्ड अबाउट व्हाट इज द एम्पीरियन लूप. इसी के अराउंड आपको क्या करना है? इंटीग्रेशन करना है. ठीक है. ये वाला. अब नेक्स्ट टास्क इज टू सिलेक्ट डीएल वेक्टर. व्हाट इज द डीएल वेक्टर? डीएल इज द करंट एलिमेंट. वी आर टॉकिंग इट फ्रॉम स्टार्टिंग. So suppose I have considered a DL vector here. Let's say this. This is the DL vector. अब DL is a vector. So what is the direction? So always remember what is the direction of the magnetic field through on that loop. You have to consider the DL vector according to that. देखो, अब I1 से if you will see the field, put the thumb in the direction of I1. The finger is curling like this in anti. What is this sense? In the clockwise sense, which means the B vector is in this direction along tangential. This is B vector, and DL vector is also in the same direction because you have considered the direction of the loop like this. ठीक है. अब देखो, फॉर I1 के लिए दिस B वेक्टर इज पैरेलल टू द DL वेक्टर, बट फॉर I2, इफ यू टॉक अबाउट I2, देखो डाउनवर्ड है, ऑपोजिट आ रहा है. ठीक है. तो उस ये है क्या है? B1 है, और ये क्या हो गया? B2 हो गया. तो B1 और B2 दोनों क्या हो गए? ऑपोजिट. तो इसके लिए हम कैसे लगाएंगे इलेक्ट्रिक फील्ड का? नेट इंटीग्रल ऑफ B वेक्टर डॉट DL वेक्टर इज इक्वल टू म्यू नॉट टाइम्स I1. Either you can consider I1 as positive, so you have to consider I2 as negative. You will consider I2 as negative, so you have to consider I1 as positive. It's up to you. So I'm considering I1 as positive, so it will be plus I1 minus I2. Simple hai. Very simple. Clear? So this is how we are going to apply the line integral for this. चलो अब सबसे पहले सवाल करते हैं. तो मैग्नेटिक फील्ड ड्यू टू इनफाइनाइट करंट कैरिंग वायर. देखो इस इनफाइनाइट करंट कैरिंग वायर का वी नो द मैग्नेटिक फील्ड by that formula sin phi 1 plus sin phi 2. So it will be mu naught I upon 4 pi e into sin phi 1 sin phi 2. Phi 1 phi 2 will become 90 degree. It means 2. So it is mu naught I upon 2 pi a. So it should be coming with the help of Amperian loop. It should be coming as mu naught I upon 2 pi a. In that way, Ampere circuital law is okay. ठीक है. So देखो, first of all, let's say this is the direction of current in this infinite wire. अब इस वायर से किस तरह का मैग्नेटिक फील्ड डेवलप हो रहा है, फर्स्ट ऑफ ऑल वो आप चेक करो. ठीक है. सो इससे सर्कुलर लूप बन रहे हैं, सर्कुलर मैग्नेटिक फील्ड डेवलप हो रही है, इस तरह की मैग्नेटिक फील्ड डेवलप हो रही है. सो आपका क्या टास्क होना चाहिए, एट द मोमेंट यू नो कि these types of magnetic field is generating here, so in that case what you will do, consider the loop as same. ठीक है, क्योंकि मुझे क्या करना है, आई हैव टू मेक बी इज टेंजेंशियल और नॉर्मल और वैनिश. सो इन दैट केस बी तो वैनिश तो नहीं होगा बिकॉज देर इज एग्जिस्टेंस ऑफ मैग्नेटिक फील्ड. बी इज ऑल्सो, if you will see here, b is inside to the plane, and at this point b is outside, which means b is somehow circular. This is the pen, and b is circular like this. ठीक है, so I have to consider the loop in the same way. So I have to consider, अब मैंने ये लूप कंसिडर कर लिया. ठीक है, ये मेरा सर्कुलर एम्पीरियन लूप. ठीक है, अब मेरा क्या टास्क होगा, लाइन इंटीग्रल ऑफ बी वेक्टर डॉट डीएल वेक्टर इज इक्वल्स टू म्यू नॉट इनटू आई. I enclosed is I only because this current is enclosed by this loop. ठीक है, now क्या B change हो रहा है at this distance? Let's say this distance is E. At this distance, what if the B is changing or not? No. यहाँ पे भी distance A है तो magnetic field same रहेगा, direction is changing. ठीक है, so we can say magnetic field is not changing. We can take it out from the integration. It will only become line integral of dl vector. And first of all, let me show you the angle also. It's B dl cos of theta. Now, what is the angle between dl vector and b vector? I have told you, always consider the dl vector in the direction of magnetic field or in the opposite direction of magnetic field. So here what we will do, देखो जिस डायरेक्शन में भी मैग्नेटिक फील्ड बन रहा है उसी डायरेक्शन में डीएल वेक्टर को कंसिडर कर. तो मैंने यहाँ पे डीएल कंसिडर किया था ना, लेट मी चेंज द कलर हियर. यहाँ पे मैंने डीएल वेक्टर कंसिडर किया था. ठीक है, तो इसी डायरेक्शन मैंने डीएल वेक्टर की भी डायरेक्शन ये, और यही डायरेक्शन क्या है बी वेक्टर के लिए, टेंजेंशियल है दोनों के दोनों एट दिस पॉइंट. ये सर्कुलर, अब मैं इसे अगर इस वायर को, ये ऐसी वायर है, अगर आप इसे टॉप व्यू से ऐसे देखें सामने से तो ये कैसे दिखेगा, ये ऐसे. ये कौन सा लूप है, एम्पीरियन लूप है, और ये वायर है, करंट बाहर आ रहा है तो इसलिए मैंने डॉट से इसे शो किया. ठीक है, अब देखो मैग्नेटिक फील्ड यहाँ पे टेंजेंशियल है, यहाँ पे भी टेंजेंशियल है, यहाँ पे भी टेंजेंशियल है, इस पॉइंट पे भी टेंजेंशियल, टेंजेंशियल एट एवरी पॉइंट. So what I have considered that DL element, this is the DL element. So DL element is also considered in the same direction. Okay. Now what is the angle between DL vector and B vector? The theta will become 0 degree. Mu naught into I. Now B cos 0 will become what? Cos 0 is 1. So B you can take out. DL equals to mu naught into I. अब देखो DL क्या है, इस लूप का सरकमफेरेंस ही तो है. व्हाट इज द लेंथ, कंप्लीट लेंथ ऑफ दिस डीएल. अब आप अलग अलग डीएल कंसिडर करके, इफ यू कंसिडर डिफरेंट टाइप्स ऑफ डीएल एंड अटैच इट, सो यू विल हैव द circumference of this circle. ठीक है, so what is the circumference of a circle? It will be 2 pi into a. The radius of the circle is a into mu naught into I. ठीक है, so b vector here we have as mu naught I upon 2 pi. Don't we get the same? देखो. ठीक है, any kind of doubt in this? अप्लाई कर सकते हो, एनी काइंड ऑफ डाउट इन दिस? yes and no, quickly say yes and no. ठीक है, we have already late in the class. yes and no, any kind of doubt? Can you apply the this ampere circuital law, everyone which is present in the class?
Yes, sir.
Okay, so the next is the question here. First of all, I have launched a poll, so you have answer in the poll and mark your attendance by commenting yes in the comment box. ठीक है, बस firstly you have to mark your attendance in the poll. ठीक है, so attempt the whole poll which I have already provided to you. उसी के बेसिस पे आपकी अटेंडेंस काउंट होगी, हाउ मेनी ऑफ यू हैव रेस्पॉन्डेड इन द पोल. ठीक है, क्लियर? and who have respond in the poll, just comment yes in the chat box and then we will proceed to the question. Everyone has to respond in the poll. ठीक है, because this is not for me, this is for you, because your present is being marked based on your responses in the poll. Clear है? So only 50% has participated. So what is the answer of this question? The shape of magnetic field lines due to an infinitely long straight current carrying conductor is, okay Ganesh, one yes is sufficient. You don't have to type yes, yes, yes. The shape of magnetic field lines due to an infinitely long straight current carrying conductor. So it will be a circular loop. ठीक है? Because in the previous question we have यहाँ पे circular loop बन रहे magnetic field के. So the magnetic field is will be circular. ठीक है? So everyone response in the poll. 3 students are remaining. Just try to complete it. Why am इसके लिए तो बोलना भी नहीं चाहिए ना आप लोगों को. ठीक है? Quickly response in the poll and then ask any kind of doubt if you have. Very simple. Okay. So the lecture is being over. Only those who have responded in the poll, I'll mark their attendance and rest will be marked as absent. Okay. Okay. So 11 student has participated in the poll. Thank you. Any kind of doubt if you have, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive in the lecture and being responsive. Bye bye. Take care of yourself and enjoy your holiday. But do not forget to attend the classes. Okay. Clear? Okay, guys. Take care.